Welcome to the new unit. It's all about the atmosphere, and the atmosphere now is going to lead us to the weather. So we are on our way to some really cool stuff here. So we're going to start with atmospheric composition. Most people think it's all about the oxygen, but actually it's all about the nitrogen. It's 78% nitrogen, 21% oxygen, with a little water vapor anywhere between 0 and 4%, and some odd little things like helium, methane, krypton, hydrogen, ozone, and xenon. So when you look at the atmospheric composition, water vapors can be very important when you're dealing with clouds and you're dealing with weather issues. Carbon dioxide makes up about 1% of the atmosphere, but it is an issue when you're dealing with global warming issues. Ozone also is a big deal in the atmosphere because it's a protectorant for us, and it's one of the few things that we screwed up that actually we got a heads up on, did something about, and looks like it's actually healing. So go us. We that rarely happens. So when we do something right, I'll give us some kudos here. All right, so when we look to the atmosphere, you know we're going to have to label it into several different layers. So we're going to look at composition and temperature as the two items that we're going to use to differentiate the layers. Here we got a nice little drawing here that shows you all our different layers, where some stuff's located in it, like the aurora borealis, where satellites hang out, where meteors burn up on, where our weather balloons hang out. So we're going to start with the lower atmospheric layers, like the troposphere. It's closest to the surface, has most of the atmosphere hanging out here, includes stuff like water vapor, which means, hey, this is where weather occurs and where, unfortunately, our air pollution collects. When you look at the troposphere, this is what you think of when you think of atmosphere. You think of as you go up, the temperatures, it gets cooler. And here at this layer, it does. So it's doing what you're thinking of. But as you move past the troposphere, things get a little more interesting. The area where you're going from the troposphere to the next layer, that's called the tropopause. Our next layer is the stratosphere. It's made up primarily of concentrated ozone, which is a good thing. The stratosphere is heated because ozone absorbs the UV radiation, which is a bad thing for us. UV radiation can cause stuff like cataracts in your eyes, skin cancer, just things that we don't really want to deal with. The air also gradually increases in temperature here, so exact opposite of what you would think of, due to the ozone molecules being heated. And when you get to the top of the stratosphere, once again, that kind of section pauses there. It's going to be called the stratopause. Now our upper layers start with the mesosphere. So think of it as kind of in the middle. Starts with an M, mesosphere. The layer right above that is going to be the thermosphere, but the boundary once again is called the mesopause. And when you hit to the thermosphere, it only has a tiny bit of the atmosphere's mass. The ionosphere, that's made up of electrically charged particles and lighter gases. And the exosphere, think of exiting, leaving the atmosphere. That has light gases like helium, hydrogen, and is the outermost layer of the Earth's atmosphere. And keep in mind, as you go off into outer space, there is no definite line of demarcation. It just kind of gradually slides on out. All right, so if you're dealing with the atmosphere is an important reason why we stay nice and toasty and warm, sometimes too warm as it's going right now, but we got to talk a little bit about solar fundamentals. And as you guys probably have guessed, the sun is the source of all energy in the atmosphere. It's transferred to the Earth and throughout the atmosphere through radiation, conduction, and convection. So here's our information about radiation. Those of you that are taking chemistry and physics, you've got a good idea about radiation. To those of you who are going to be taking that, I'm not going into any details. You will get that in chemistry, physical science, or physics. All right, so how do we actually get this energy into our atmosphere to keep us warm? Conduction is your first way, and most of you guys have dealt with conduction in some form, probably when you were a little kid, like when you maybe touched a stovetop when it was on and you shouldn't have, or what I've done and still do when I'm an idiot, which is that I'm cooking soup and I leave a spoon in there, like a metal spoon, and come back 10 minutes later and you grab that metal spoon and you scream because your hands are getting burned from that. That's conduction. That's the transfer of energy that occurs when molecules collide, and it's transferred to the air near the surface. So you have if you have a metal spoon in like a pot of soup, the soup will heat up the metal spoon, and then when your hands touch the metal spoon, there's a transfer of heat right there. Same thing happens with the atmosphere when the earth heats up. When the ground or the asphalt or the sand or the rocks all heat up, the air right above it, the energy is transferred to the air right above it, and it heats that air right there. So for it to occur, you got to be in contact. So the next level is going to be convection. So remember, you have that nice heated air that's right above the Earth's surface, and that heated air is going to be less dense. Remember, heated air molecules will move apart, just like water molecules in the ocean that are warm, they move apart. Just like in the mantle, the warm molten rock, those molecules move apart when they're heated and become less dense. So those air molecules now that are less dense, well, things that are less dense, they rise. Think about a hot air balloon. So the hot air balloon, or the warm air, now rises, goes high up, and when it gets away from the earth, it's getting away from its heat source. Oh no. So now the molecules are cooling off, and they start to slide together, get closer together, become more dense. When they become more dense, they drop and move back towards the earth and warm back up again. And now when they warm back up again, they rise. So now you get this nice circular motion of warm and cool air. Here's all the information I just talked about. Remember, you can stop this video and get this information down. Alright, here's all the fun and exciting things we're going to be hitting right here coming up. And I am going to stop this video, and I'm going to kind of make this a second video for you guys.